So in this video, we're going to talk about the learning target. I can solve quadratics in standard form by completing the square. So when we solve a standard form quadratic, normally we should always try to factor first, but sometimes quadratics won't factor, in which case another technique we can solve them with is completing the square. So what I'm going to do is I'm actually going to try to factor this and solve, and you're going to see that it doesn't work, and then I'm going to show you how we complete the square. So when we factor, right, we're breaking it into the two parentheses equal to 0, and we're reverse FOILing. We're asking what times what gives me the first term. Well, that's x times x. And then I ask what times what gives me the last term. Well, 15 can be 1 times 15 or 3 times 5. And I need the combination that's going to give me 4 in the middle. Well, you'll notice 1 and 15, well, that's not going to give me 4. And 3 and 5, that's not going to give me 4 either. So notice this guy isn't factoring like we normally would, okay? So because it's not factoring and I want to solve it, I'm going to do this technique called completing the square. The way it works is I get rid of the 15 because the 15, the factors of it weren't allowing me to factor. So I'm going to minus 15 from both sides. Okay, I'm getting rid of it because it wasn't working. The numbers that it was giving me just were not working. So that'll eliminate, and I'll get x squared plus 4x equals negative 15. Now, you'll notice I left a gap here, and I did that intentionally because what I'm going to do is I'm going to add a number that will work, that will allow me to factor this. Okay, the way I get that number is I take half of the middle number and I square it. Okay, so I'm taking half of 4. Well, half of 4 is 2, and then I want to square that number. So if you take 2 squared, you get 4. Okay, so just to recap that, I'm taking this guy, the b value, and I'm taking half of it, and then I'm squaring whatever that is, and that's the number I'm going to add. Now, I can't just add something to the left side of the equation, right? That would throw off the balance of the equation. So if I add it to the left side, I have to add it to the right side. Okay, so I have to add 4 to both sides. Now, when I do this, it'll now allow me to factor the side that I wasn't able to factor before. So if we try to factor it now, you'll notice x times x gives me the x squared. And what number multiplies the 4 and will add when I check the O and the I to 4x in the middle? Well, that's just simply going to be plus 2 and plus 2, right? 2 times 2 is 4. I'll get 2x in the middle and 2x on the outside, which gives me 4x when I add them. And then on the right side, I can just put these numbers together. That's going to be negative 11, okay? Notice that when you complete the square, these parentheses will always be the same. They'll always come out to be exactly the same because you're completing a square. And when you multiply something by itself, if I take x plus 2 times x plus 2, I get x plus 2 squared. That's why we call it completing the square, because when you do this, when you add this number that allows you to factor, you're completing a square. You're getting a square when you do it. And then if I want to solve this to get rid of the square, I can take the square root of both sides. That'll give me x plus 2 equals plus or minus the square root of negative 11. Now remember, negative square roots are imaginary numbers, so I can simplify that by pulling out the I, the imaginary number, and leaving the square root of 11 underneath the square root. And then that equals x plus 2. And then my last step is just to minus 2 from both sides. So my final answer is going to be x equals plus or minus I times the square root of 11 minus 2. And that is my final answer. Okay. So just to kind of recap there, what we did is you try to factor first. If factoring doesn't work, completing the square is just another option for you. Okay. So we get rid of 15 because 15's factors weren't working, and we replace it with a number that will allow us to factor. The way we get this number, which is kind of the major idea here, is you take half of the b value and you square it. Okay, so half of 4 was 2, and 2 squared is 4. Okay, so let's go ahead and look at another example of this. So if I look at number 2, I have x squared minus 10x minus 4 equals 0, and it's not going to factor. Okay, I'm not going to show you again. It just take my word for it, it's not going to factor. Okay, so we need to get rid of the 4 so that we can replace it with something that will allow it to factor. So I get x squared minus 10x, and I'm going to add something. I don't know what that is yet. I'll calculate it in a second. And then 0 plus 4 is 4. But because I'm adding something to the left side, I need to add something to the right side. Okay. Now is the part where we're going to complete the square. So I take half of the middle term, which is negative 10. And then if I take negative 10 and I take half of it, well, that's going to be negative 5. And then if I square that, well, negative 5 squared is 25. So I'm going to put 25 on both sides. Okay, so once again, I'm getting this number, half the middle, which is negative 5, and then I'm squaring it. Negative 5 squared is 25. Okay, so I'm going to add that to both sides. That allows me once again to simplify the left-hand side. It's now going to factor, okay? So x times x gives me x squared. What times what multiplies to 25 and adds to a negative 10? Well, that's negative 5 and negative 5, right? And notice, once again, these should come out identically the same, which is going to give you x minus 5 squared, right? It's going to lead to a square, which is why we call it completing the square. You're going to get a square when you do this, okay? And then that equals 4 plus 25, which is 29. And then I can solve this guy. I can take the square root of both sides. The square and square root will cancel. I'm left with x minus 5 equals plus or minus the square root of 29. And then I just simply add 5 at the end. So I get x equals plus or minus the square root of 29 plus 5. All right, we are now going to look through 2 more examples here. So if I look at number 3, you'll notice here that I have variables on both sides. I want to get everything on one side. So I'm going to move the 6x over by adding 6x. So I get x squared plus 6x minus 2 equals 0. Now, this isn't going to factor, so I got to get rid of this last number. So I'm going to add 2. That gives me x squared plus 6x. I'm going to leave a space so I can complete the square. That equals 2. And then because I'm adding something to this side, I have to add it to the other side. Now, the key here is how I get this number. I take half the middle, well, half of 6 is 3, but then I have to square it, right? I'm completing the square, I need a square. 3 squared is 9. Okay, so I'm adding 9 to both sides. Well, that's going to give me 11 on the right side, and then I can factor now the left side. It's going to be x times x is x squared, and then 3 times 3 gives me 9, and we'll add to 6. Notice those are the same, so if I multiply them together, I get x plus 3 squared, not cubed, sorry, x plus 3 squared equals 11, and then I just take the square root of both sides. That gives me x plus 3 equals plus or minus the square root of 11, and I can just minus 3 here at the end, and that'll give me x equals plus or minus the square root of 11 minus 3. All right, one last example to run through here. Once again, we want to get everything on one side to start, so we're going to add x squared over. The x squared term is going to come first, then the 4x, then the negative 24 equals 0. It's not going to factor, so we're going to add 24 to the other side. That gives us x squared plus 4x plus something equals 24 plus something, right? We got to add it to both sides. And to get this number, you take half the middle. Well, half of 4 is 2. And then you just square it. Well, 2 squared is going to be 4. And then we're going to combine those. Well, that's 28. If I factor this guy, I'm going to get x times x is x squared. Positive 2 times positive 2 is 4. And we'll combine to give me 4x in the middle. Notice they are the same. So I get x plus 2 squared equals 28. And then I can take the square root of both sides, which will give me x plus 2 equals plus or minus the square root of 28. Notice there is a perfect square that goes into 28, right? 4 does, so I can rewrite that as the square root of 4 times the square root of 7 equals x plus 2. And then really the square root of 4 is 2, so I get plus or minus 2 square root of 7. And then I know I'm going to subtract the 2 over from both sides, so I can subtract the 2 now. And my final answer here, squeeze it in at the end, is going to be x equals plus or minus 2 times the square root of 7 minus 2. Okay, so just to recap kind of what we're doing here when we complete the square. It doesn't factor, so you get rid of the last term. You're going to replace it with half the middle term squared. That allows you to factor this side. In fact, not only will it factor, but it'll be the same two factors that form a perfect square. So it's the factor squared. You take the square root of both sides and simplify. Now, the last thing I want to mention here before I end the video is that when we complete the square, we do so when the a value is a 1. Okay, if the a value is not a 1, we're going to solve these a little bit differently. But whenever the a value is a 1, completing the square is a good option to use when it won't factor. Okay, so you'll notice on all of these, the a value was always a 1, right? Once I moved it over, it was a 1 here. So only when a is 1 will we use completing the square.